Chapter 10, chemistry practice test, here we go. First 32, I don't really have a vision for reading all of them, but I would read some of them if you wished me to. It's the same thing we just did on the 10-7B quiz. We've sort of been there, done that. But does anybody want me to say anything off the first 32 just to make absolutely sure that you're good? So then we kick in on problems. Let me do answers first, and then we'll double back and layer in details as needed, sort of one page at a time. So one, I'm going to say 97.0. I'm going to want to do the three significant digits. So 97 is only two digits. We need the 0.0 to make a third digit. And then grams, and then also put ZnCl2. Before you would turn your test in, I'd highly recommend you do a skim. Count three digits. Make sure there's a unit like a gram or a kilogram or a liter or a mole, and then also make sure there's a substance like an HCl or a H2SO4 or whatever that may be asking about. But one, I'm hunting 97.0 grams ZnCl2. Two, we're hoping for 1.42 grams H2. Three, we're hoping for 0.858 kilograms. So this one is one step longer to get 1,000 involved in the dimensional analysis at the end. 0.858 kilograms Fe2O3. Four is 0.171 moles BaSO4. That one is one step shorter because we got to stop on moles. Five is 20.6 grams CO2. That one's also one step shorter because we started with moles. Six is the shortest one of the page. It's only a two-step plan, the original line and then one line of math. It's 0.632 moles HCl. And then 7 to 9 starts our first limiting reagent problem of the outing. We're hoping for a 0.198 grams of H2. 0.198 grams of H2. So then let's layer in some help on that page. Anybody have something that did not go well? Yeah. First one. So did you have 46.5 in the first slot? Then on bottom of the second slot, a 65.4. Okay. Do you understand? Okay. Do you understand how I'm getting that? Then a 1 over a 1 in the middle, and then the final math number would be a 136.4 on the top. Did you have a 136.4? Do you know how to get the 136.4? Yeah. And then that should do it for you then. Anything else go wrong? Yeah. 3. Did you have 945 in that first slot? Then the second slot, bottom, 87.9. Okay. Because we grab the iron number, which is, I think, in the 50s, plus the sulfur numbers in the 30s. Does 87.9 make sense?
Yeah.
Okay. In the third slot, did you go 2 over 4? Okay. There we're using the coefficients from the equation. So since I gave you the 945 was the FES, we'd want to do FES on the bottom. And I brought the 4 from the equation. Whatever I give you is going to go on the bottom of the mole to mole. So since I gave you FES, do moles FES on the bottom, grab the 4. Do you want me to rewind that, or does that make sense?
I think I'm doing that.
What did you say?
I think I'm
All right.
Yeah.
On top of the mole to mole, you want to do moles of what we're hunting. So what I'm asking you about is iron oxide. So on top of that, you'd want to go moles of Fe2O3. And the number for moles for the top of that would be the 2 that's with the Fe2O3 in the equation. It's the 2 over 4. Does that make sense?
Yeah.
Okay. Then in the fourth position, I'd go a 159.6 on the top. Are you okay with 159.6 or want me to explain that? Yeah. So we need to go to periodic table for the Fe2O3. Fe was in the 50s, so take that 50s number times 2. Plus oxygen's definitely 13 or 16. So do 16 times 3. And so that 50 something times 2 plus 16 times 3, that should get you the 159.6. Is that okay? Then the very last step that only happened on this problem, and I don't know that it happens again on the whole test, I went to kilograms. So we're going to need to do a 1 kilogram on top and 1,000 grams on the bottom. Does that make sense at the end? So grand total there on top, I had a 945, then I had a 1 over an 87.9, then a 2 over a 4, then a 159.6 over a 1, and then a 1 over 1,000. Is that okay? Anybody else on the page to 9? Anything I can do on the page to 9? Moving up the page then, I guess. Flipping up the page to number 8. To do 8, you'd have to have 7 right. If you didn't get 7 right, 8 is just not going to work. But if 7 was right, we've got a chance. It's going to be 48.0%. 48.0%. Likewise for 9. 9 can only happen if 7 was right. That's going to be 0.0500. When I do that, that's a 3-digit answer because the 0.0, that first 0 doesn't count. 5 is the first digit, so it's significant. And then I need a 00 to get up to 3. So 0.0500 moles H2SO4. 10 is a 1.43 liters H2S. 11 is a 12.1 liters H2. 12 is a 0.0955 moles KClO3. 13 is our second limiting reagent problem. 13's answer is going to be 15.8 liters of H2. And then you need 13 right to get 14 right. 14 is going to be 0.304 moles Fe. 0.304 moles Fe. 15 you can do in a very short, just one-step move, just using the coefficients. Liter to liter, volume to volume questions. You can just do that with the coefficients. 15 is 1.81 liters N2. 1.81 liters N2. Anybody need help that page, including going back to maybe do 7 to open the door to get 8 and 9 a possible shot, because 8 and 9 again relied on 7. Anybody have something going on that page? Yes.
Can we go back to 7?
Yeah, I was surprised nobody asked about 7 when we were there, but if no one cared, I wasn't going to bore you with the details of it all. For 7, we need to do a 2.4 grams of magnesium move. Standard operating procedure is get from grams to moles. Then you want to get from moles of known to moles of unknown. In this case, magnesium is what we knew, and H2 is what we're hunting. Before I even fill in any numbers, I might as well get the other options started, because the limiting, I gave you 2 things to start with. So we've got 14.6 grams. Sulfuric acid is the H2SO4. So I need to get from grams again, as always, to moles. Then on the bottom, I need moles of the known. And up here, moles of unknown, which was the H2. That's kind of the structure of the whole page, how even 1 to 6 are going. That's how a lot of these start, with that kind of movement. You okay with that so far? Okay, then if we layer in numbers, this mole number is a 1 when we go mole to gram. This is a 1 when we go mole to gram. How do we get the gram numbers? Periodic table. So magnesium's 24.3. H2SO4 is 4 16s plus a 32 plus a 1. I think the 32 has a decimal on it. It comes up as 98.1. Any of the periodic tables, you want to round them to the tens place. So this is 1 even, this is 16 even. I'm pretty sure this is 32 point something that rounds to 1. But that's going to make a little bit of a difference. Question about that? 98 is adding up 2 of the 1s from the periodic table of hydrogen plus a 32.1 for sulfur, because I think it's 32.06. Somebody table handy, is it 32.06 and it rounds for sulfur?
Yeah.
Yeah. So we'll make that 32.1. And then 4 of the oxygens, oxygen is 16 even. So 4 times 16 plus that 32.1 plus 2 of the 1s makes the 98.1. You good on that? The mole to mole numbers, where am I grabbing all of these mole to mole numbers from every time? The coefficients. So fortunately for us, the coefficients in this equation were all 1s across the board. That's kind of rare, but that is what it is on this one. Question about any of that? Okay, then we do some partial punchings. On these limiting reagent problems, do this divided by this and write it down. It's 0.0988. That's worth nothing now, but we're going to need that when we flip the page. This is 0.1488. That means nothing now. It's going to mean something though when we flip the page. Usually these aren't 1s. So usually the numbers that matter are different than the ones that we circled. But that didn't happen here. This would get us a 0.0988. This would get us a 0.1488. And then we make a decision, one of those numbers becomes the more important number. Which one's the more important number? Yeah, why is this more important? It's smaller. The one that's smaller matters. That tells us that this is the limiting and this is the excess. And I tend to write limiting and excess like all over the place because I'm going to need to know that in a minute when I turn the page. And then the one that's the limiting, we're going to layer on one more level of math. We're going to get from moles of H2 to whatever we're hunting. What are we hunting here? We're hunting grams of H2. So again, the number for moles when we have moles and grams is always 1. And the gram numbers always come from the periodic table. And that's going to be a 2 because hydrogen is 2 times 1. Push a bunch of buttons and we're hoping to show up a 0.198 grams H2. That's your question. So are you good with what happened there? Yeah. Anybody other than the requestor there have anything about any of that? So that opens the door to keep talking about 8 and 9 if 8 and 9 gave people trouble, or anything else on that page that goes to 15. Anybody have anything on the page 8, 9 up to 15? Anything that's going bad? Going badly. I guess I should use correct grammar.
Did you say the final answer is 17
It's final answer to which one?
17.
7. 7 will be 0.198 grams H2. 9. Okay, so on 9, when we figure out who's left, we always start from the moles of limiting, which is circled. It's always circled if you follow my circle motif. So the moles of limiting is that number. Then we need to convert from moles of limiting to moles of excess using the coefficients. In most of these problems we've done, those have been numbers other than 1s. but in this case, I gave you an easier one. The numbers are all ones. That isn't going to change. And this would tell you 0.0988 moles of excess that got used up. And we're most of the way there with that number. You okay with that? If we subtract that from the moles of excess that there originally were, and that's our other circled number finally gets to come into play. The 1488 from a little bit ago subtracts the 0988 that we just mathed. Subtract that, that's a 0.0500 moles H2SO4. Is that okay? Anybody need 8 to complete the trifecta on the limiting reagent problem? Or anybody have anything else on that page that's not working?
We do
8. So 8, we're going to take the 0.095 that I'm giving you in 8, divide by the 0.198 that you got back in 7, and then times 100. Because we have a vocab answer where you say to take the actual, which is the 0.095, divide by the theoretical, which was the 0.198, times 100. Anybody else stuff to 15? Yeah. 11. So 11, I did 0.359 in the first slot. And then I did a mole to mole using coefficients 3 over 2. Are you okay with 3 over 2? Yeah. Then we're going to go moles to liters. That's going to do a 22.4 on the top and a 1 on the bottom. So across the top, there's a 0.359, a 3, and a 22.4. Across the bottom, we had an empty box, a 2 and a 1. You good with pulling those numbers? Anybody else? Anything that's cooking on page 15? Anything that has you not confident? 13, 14. Okay. Is there anybody that needed this anymore? I'll just reuse this space then. Has 56.3 grams of iron. So as we usually do, we need to get from grams to mole number for that. 1. Gram number for Fe, you're going to grab from the, you're okay, 55.8. Then we're going to go from moles to moles with Fe on the bottom, and what we're hunting on the top, we're hunting hydrogen. Mole to mole on that, I'm again being kind to you because the numbers are all 1. Usually they aren't, but I don't know if by accident or on purpose, I picked out a couple nicer ones for you. Question about that first line. The second line, based on 69.2 grams, H2SO4. So again, grams goes to moles. This is a 1. This is coming from the chart. We did that already. I think we had a 98.1 already in another problem with H2SO4. Then we're going from moles to moles. H2SO4 is going out because that's what was in. H2 is what we want. And again, the coefficients are all 1s. Question about the math setup of that. And we push some buttons. So I go 56 dividing 55 and write down a 1.00896. And I circle that. I'm going to need that in a minute. I would go 69 divide 98. That's going to be a 0.7054. I'm gonna need that in a minute. Usually I have more numbers here to punch, and the numbers here are different than they were there, but they're not this time again. It's this and this stay the same. These are our decision-making numbers. Here's the more important number, the bottom one, because it's smaller. So this is the limiting, this is limiting, H2SO4 is limiting, iron is excess, this number is excess, and then the limiting question, I should have probably written this like out of the way somewhere, but when we go to finish the limiting question, I need to get from moles to liters. The number for moles to liters with mole is always 1. The liter number, 22.4. So we're going to punch this one all the way in to get the answer to 13, and it should be 15.8 liters.
Did you say it
15.8 liters, H2. You good on that? Then where's, always we do this structure, moles of limiting is our boss. Where do we grab moles of limiting from? Circle. It's this one because I labeled it 7054. In other questions, in other times, in other homeworks, in other moments, these are numbers other than ones, but here they're ones. So this 7054 stays the same. That's the moles of excess that got used. So how do we figure out the moles that are left? Subtract that from the original number, which is up there circled. Take the 1.00896 and subtract the 7054, and that'll get us our leftovers. More there? Back page. 16's our another limiting reagent problem, final one of the day. 16, we're hoping for 6.34 liters NO2. 6.34 liters NO2. Second one is 5.29 liters O2. 5.29 liters O2. 18's exothermic. How do you know from just visual analysis? The heat's on the right. So if the heat's on the right, that's exothermic because the heat's going out. If the heat were on the left, you'd instead do endothermic. So 18 exothermic, there's an easy one hopefully. 19 is going to get you 15.6 kilocalories. 15.6 kilocalories. 20 is going to be CH4 plus 2 O2s once you balance it, then the arrow, CO2 plus 2 H2O once you balance it. 21 would be a 0.793 moles O2, 7.93 moles O2. Then the last one's 35.6 liters CO2. 35.6 liters CO2. If that were a test, then that's my moment. The next thing I would do is very carefully go back through again, saying it for the second time today. Count 3 significant digits on every answer. Look for a mole, a liter, a gram on every answer, and look for like a CO2, H2O kind of thing on every answer. You don't want to lose half points over like petty little things like that after you've got the numbers. Back page, what can I do for you? You'll have to do that for yourself, but yeah. Anything else on the back page? Yeah. Okay, so methane is just the thing that you're going to need to know, that methane is CH4. At some point this year, before I took the scene, you had a quiz you did that had like muriatic acid and quicklime and all this stuff on it. Methane was one of those, and methane's been on and off throughout the year. Methane's just natural gas. So I would imagine the test tomorrow is going to have methane on it, so just know that methane is CH4. It burns in oxygen, so we go plus oxygen. Some other time in the year before I took over, you memorized a bunch of diatomic molecules, IONFHCl and IONFHCl, BRI. I said I already. There was like 7 or 8 of them. Oxygen's one of them. Oxygen never comes as O, it comes as O2. We're burning that, and it says we produce carbon dioxide, which is CO2. That name had to do with another chapter before I was doing this year that was like di, tri, tetra, all these prefixes, but carbon dioxide is CO2. And then water, we should all know, is H2O. You okay with writing that stuff? And then for balancing purposes, the H's are wrong and the O's are wrong. So here I have 3 O's, here I have 2 O's. H's I have 2, over there I have 4. So I'm going to put a 2 there to balance the H's, and at the same time I accidentally balanced the O's, almost. I at least got the O's to be an even amount. Now I have 2 O's and 2 O's is 4 O's. The 2 there gets me 4 O's, and now I'm completely balanced. That's like a chapter 9 moment. Okay with that? Then you want me to do those other 2? Okay, so then we're going dimensional analysis. So as usually happens, you're given grams. We're given grams of methane. So generally, you go from grams to moles. CH4, this number, a gram mole, always 1. Gram number comes from the periodic table, it's going to add up to 16. Then we always convert from the moles of known to the moles of unknown. So the moles of what we had all along is going bottom. The moles of what we're hunting, which is oxygen, goes on the top. This number finally isn't a 1. It's a 2. So I'm going to grab the coefficient, and finally there's a coefficient other than a 1 to grab. And this one would be 1. Because it's way back to the beginning. Okay with that. The next one is almost the same, but we'll let that one settle in for a minute. Anybody 21? Anything about that that's bad news? Okay, then a slight change. I say, okay, it's not 6.34. It's now 25.4. But it's still methane. But it's not oxygen anymore, it's CO2. So the number for CO2 is a 1. And I don't think I stopped there. No, I didn't. I want to go from moles to liters. The number for moles, 1. Liter number always 22.4. And then that should work.